Hey guys, it's time for us to turn our attention to another efficiency mechanism that Cisco has provided us that's going to allow us to propagate VLAN information in our infrastructure, and that tool is VTP. VLAN Trunking Protocol is the application-specific utility that Cisco created in order to make our lives easier when it comes to sending information associated with VLANs across our infrastructure. Now, what we're going to find is that throughout our discussions, Cisco utilized or created this solution, but what we're going to realize very quickly is the fact that it's something they kind of backed out of. I alluded to that in one of my other presentations, and that's the simple fact that VTP, if we are not careful, can be very, very problematic for us. In fact, my predecessor had a term that he used, and that was called a VTP bomb, implying that it was going to blow your entire infrastructure to smithereens. Well, that may or may not happen depending on how careful we are, but what we're going to realize is that through the use of this concept of VTP, we have now different options and different choices. Now, the main purpose behind having this VTP concept is for the sole and express purpose of advertising VLAN information. Again, it's an efficiency mechanism. It's designed to make our lives easier by reducing administrative overhead. And the thing is that what we have to recognize is that VTP really doesn't have anything to do with trunking, other than the fact that we need trunks in order to be able to send information associated about different VLANs. It's really just a management protocol. And by virtue of the fact that it's a management protocol, it's going to be one of those things that Cisco's definitely going to want us to know about in the confines of the RS version 5 CCIE exam. Now, when we go in and we start looking at this, what we have to recognize is that we may have our infrastructure. Let's just draw maybe 4 switches here, and they may be interconnected. They could even be cross-connected for that matter. In fact, we know beyond a shadow of a doubt if we're going to be using VTP, these are going to be trunks. And as trunks, we're going to be utilizing these links to carry information about different VLANs. Now, what we need to understand here is that before VTP, we had to go from device to device to device to device in our infrastructure and configure all of our pertinent VLANs. Now, VTP gives us the capability of being able to communicate that information through this idea of this management utility that Cisco has brought to us. And the other part of this is we also need to recognize here the fact that when we set up our infrastructure where we create these switches, what we can do is we can create something referred to as a VTP domain. Now, a VTP domain is going to be where we have a single instance of VTP running. It's not like spanning tree per se, but still some of the behaviors are very similar. When we go in and we create and do our switches, say for instance we have Catalyst 1, Catalyst 2, Catalyst 3, and Catalyst 4 in our infrastructure, we need to understand that if we're going to operate completely and successfully among all of these devices, they need to be in the same VTP domain. Now, the other thing is that we also have to recognize we have this idea of password. Now, this password is for authentication. Now, remember, when it comes to authentication, what am I talking about? I'm talking about devices communicating with each other and providing them or affording them a mechanism by which they can verify the identity of their neighbor beyond a shadow of a doubt. That's the idea. Now, what we're going to find is as these hashing algorithms that we're going to be discussing have matured and as the industry has matured, there have been solutions or tools, capabilities, and hacks that allow people to overcome some of these, and VTP is probably not the most bulletproof, but again, what we are going to try to ensure here is that someone can't go to like eBay, buy a switch, plug it up into our infrastructure, and start participating in our VTP domain. Now, when it comes to VTP, it's like every other protocol we're going to talk about in the fact that it has matured. VTP has matured over the years, first having what we refer to as version 1, version 2, and then now new to the CCIE routing and switching track, we have to deal with version 3. Now I'm going to talk about version 3 cursorily in this portion of our presentation. However, after we do the demonstrations for VTP 1, VTP version 1, version 2, what I'm going to do is I'm going to have another set of videos and another presentation dealing specifically with VTP 3. Now, VTP version 3 gives us a lot of efficiencies, but I really don't want to spend time talking about that now. I want to focus on the basics of VTP version 1 and version 2, so that when it comes time for us to talk about VTP version 3, we're going to be able to understand why these efficiencies and why version 3 was actually created. So in the confines of version 1 and version 2, we have, what was it my predecessor used to call it? Myth busting. Yeah, myth busting. Now, I mean, I'm not too keen on going in and trying to find out exactly where the document CD is incorrect or exactly where documentation is incorrect. However, on the same side of that coin, I don't like propagating erroneous information. And this next portion of our presentation is from Cisco's materials, and it is, in fact, erroneous. Now, what's it saying here is it's telling us that version 1, if I operate as a transparent switch, is going to inspect all VTP messages, and it's going to check them for my domain name and my version. And then what it's going to do is it's only going to forward that information if this information matches the local database configuration, the local VTP configuration. Now, what that is also saying here is here is the erroneous part, and we'll illustrate this when we get to it. And that's going to be version 2. They say version 2 as a transparent switch will forward VTP messages without inspecting them. Now, what's the myth here? That entire statement is the myth. What we're going to see is in the old version of iOS and in the current version of iOS, if the VTP domain does not match, whether it's going to be in transparent or otherwise, a version 2 switch is not going to forward VTP messages. So it's going to actually drop them. And we'll be able to see that when we get into our demonstration, when we start looking at it. But like I said, I hate disseminating erroneous information. So it's not really so I can pat myself on the back and prove that I've demonstrated that Cisco is wrong. I just simply don't want you guys to listen to something that I say and carry it into your deployment and discover later on that it's not exactly accurate. So when we look at this, the main thing that we need to recognize is that with our routing protocols, as with all other components, VTP supports different features. It supports what's referred to as our normal VLANs. Now, if I want to create an idea of extended VLANs, and one of the reasons that I may choose to create extended VLANs is to support something called private VLANs, which is something we'll talk about in the confines of security. But again, you know, this whole idea is how do you eat an elephant? And like I said, it's one bite at a time. So it's not just necessarily one bite at a time. It's also based on where we're starting. We're starting at layer 2. And what we'll do is once we've got mastered all of the components behind layer 2, we'll move to security and we'll talk about things like private VLANs. But the thing that I want you to understand is that VTP version 1 and version 2 cannot propagate information about extended VLANs. So what ends up happening is if I want to be able to use extended VLANs, I have to disable VTP in the form of this transparent switch operation. What we're going to find is we have server, client, and transparent. We also have another mode now in the confines of our system referred to as off. Now when we look at this, servers in VTP 1 and VTP version 2 have the capability of creating VLANs. Clients have the capability of learning about VLANs that were created by servers and passing that information on to their neighbors, but I do not have the capability of going into a VTP client and creating a VLAN. Now, the last element here is a transparent VTP switch. Well, a transparent VTP switch, I could create VLANs locally, but that information is not going to be propagated to neighbors in my VTP domain. Secondarily, when I receive an update from a VTP server, I'm not going to implement that update. However, as a transparent server or as a transparent VTP-enabled device, I will forward that information on to my neighbors. And that again alludes to this idea of exactly what information will and will not be forwarded in our infrastructure. And that's one of the things I definitely want to take a look at inside the confines of our large layer 2 topology that we have through our virtualization tools. Now the other part of this is like I said, private VLANs. Private VLANs give me the capability of being able to take an individual VLAN and break it up into smaller VLANs. So think of it kind of like VLANs for a VLAN. So the main goal here is it's considered to be a security mechanism. And as a security mechanism, we'll definitely cover it when we get to our security conversations. One second here, let me advance my presentation. So, like I said, let's go over these modes. I've already alluded to it. In server mode, we have the capability of being able to create VLANs. We also have the capability of sending VTP messages to our neighbors so that we can communicate the existence and the necessity to create those VLANs to our neighbors. That's going to be for what's referred to as our normal VLAN range. And that's going to be anywhere from VLAN 2 all the way up to VLAN 1000. Now, what we also have to recognize is that we have extended VLANs, which are going to be VLANs that are going to be above 1005. Remember, VTP version 1 and VTP version 2 do not allow us to propagate or disseminate information about these extended VLANs. And also, it does not allow us to communicate or extend information associated with private VLANs, which we'll be talking about in their own section. But it's also important to realize that VTP version 1 and VTP version 2, being a Cisco proprietary solution, was not built out of the gate to be able to communicate information about other types of spanning tree. For instance, multi-instance spanning tree, MST. Therefore, Cisco saw the necessity to be able to create this idea of VTP version 3 that's going to allow me to propagate information about extended VLANs, about my normal VLAN ranges, about my MST, and also through the utilization of TLVs, type linked value fields, we're going to be able to have the capability in the future to support other topological utilities that we may use at layer 2. So looking at this, let's take a look at this and just go through cursorily. Like I said, server gives me the capability of being able to create VLANs. VLAN configuration is stored on flash in a file called VLAN.dat. We have the capability of supporting the range of VLANs via VTP, which means we're sending messages out that are communicating the identity of VLANs in the range of 2 to 1000. That's on a server. And the other thing is every device in our infrastructure is going to be a server by default. So looking at this, the other mode that we have is client. Clients actually get their configuration from servers. We don't have the capability of creating VLANs in the command line on a client device. The other part of this is that we can't make any changes to anything that we would necessarily want to be able to propagate via VTP. So again, that's a very important thing to understand. Now, we will discuss this idea of the VTP bomb, but understand this, and that is the fact that as we use a tool like VTP, a lot of companies shied away from it, and the reason that they shied away from it was because of the fact that when you start implementing and making changes, sometimes what can happen is you can force your layer 2 environment to reconverge. For instance, we may have VLANs that are active on one device that aren't active on another. We also have this idea of propagation delay, whereby it may take time for something from the edge of our VTP environment to get propagated all the way to the corresponding or the exiting edge. So a lot of companies really got rid of this idea. And the other thing is in the confines of the fact that every device defaults to server, that means by accident I can erase, delete, or replace VLANs if I'm not watching what I'm doing. Therefore, making VTP something that a lot of companies shied away from because they saw it as being dangerous. Now, when we look at this, VTP changes, like I said, are not allowed on clients. Now, the VTP changes that are applied, i.e. the ones that are learned from our server, again, are stored in this file called VLAN.dat. Now, the reason I'm saying this is that if I erase my configuration and I reload my device, if I've left this VLAN.dat file in the system, it will reload it, which means I'm going to erase my running configuration. However, my VLANs, my VLAN database will be repatriated to my running configuration, or to my NVRAM, my non-volatile, my RAM. It's going to be loaded up into running memory. And what's going to end up happening is those VLANs are going to still be persistent. So if I want to eliminate, delete, or reconfigure VLANs, it's very important for me to understand that I need to remove this file before I reload my devices. Now, that's going to remove the configuration requirements and the configuration settings for my VLANs and any of my VTP settings to include my VTP domain. Now, continuing our conversation, what we're going to find out now is we have that other element that I wanted to talk about, and that's going to be the idea of the transparent device. Now, like I said, TLVs are the primary enabling utility that allows VTP to expand to support other protocols or features over time. In fact, it's TLVs that made version 3 available to us in the very, very beginning. So when we go through and we start looking at this, what does a transparent switch do? Well, a transparent switch supports extended range VLANs. So any VLAN from 1006 all the way up to 4096. Now, keep in mind that we can create them on this device, but VTP is not going to be used to send that any information to any other device. So by telling that it's a transparent VTP device, what that means is we're going to change its behavior. Remember, I said servers and clients store their database in flash. A transparent switch stores its database in the running configuration. If you do show run, you'll be able to see your VLANs. If you do show run on a client or on a server, you're not going to be able to. Now, the other part of this is that we need to recognize the second most important part here. And that is the fact that we can create VLANs and they're not going to be propagated. The second most important part is that when we receive VTP update messages from a server, we are not going to implement them. We're not going to actually apply those updates. However, we will forward those updates onto our neighbors on a link-by-link basis. So the idea here is by virtue of the fact that we have a transparent switch in our infrastructure, we're not creating a quote-unquote black hole for this idea of VTP propagation. However, it's important for us to understand that if we communicate the existence of VLANs to our neighbors, but we do not create those VLANs on our own device since we're a transparent switch, we can have black holes with regard to actually sending traffic associated with those VLANs. What do I mean by that? Well, if I mean my neighbor knows about it and my other neighbor knows about it, and I'm the only device between those two components that are going to allow frames to be forwarded, what's going to happen is if I don't know about the VLAN, I'm not going to have a running instance of spanning tree for it. If I have no running instance of spanning tree for it, I will not be doing any type of listening and learning. Therefore, I will record no MAC addresses. So the net effect here is that I'm not going to pass that traffic simply because that VLAN does not exist to me and I do not know how to handle it, nor do I know what interfaces to send it out of. Again, based on this idea that I don't have any MAC addresses in my CAM table. Now, how do I know or recognize that a device is operating as a transparent switch? Well, we have this idea of revision. What I want to do is I want you to think of revision for VTP as a level of believability. So the higher the revision, the more believable the database is because it's existed for the longest period of time. That's the implication. However, if I go to a device and I say VTP space mode space transparent, what's going to happen is it's going to take that VLAN database, is going to take that revision and it's going to take it down to 0. Now I can add VLANs ad infinitum on that transparent device. I could add 50 VLANs individually, and what's going to happen is my revision number is going to remain the same. So the main thing that we want to understand out of this is that if I were ever to bring a device out of transparent mode, every other device that it would now be trying to communicate with and send information would see this VLAN being 0 or being incremented to 1 if I added VLANs or higher. So what's going to happen is it's going to make certain that this VTP transparent switch, when it becomes a participant in the VTP domain, we're not going to believe any of the prefixes that it has because it hasn't been participating in VTP up to this point. So again, this is going to be a useful tool, but it's also one of the main reasons that a lot of people do not employ VTP in their environment. Because when we go in and we start looking at how things are set up with regard to VTP, it's this idea of the revision number that can cause us problems. So let's focus on something here. Let's focus on the actual importance of these bad bears. So what is the importance of the revision number? Well, like I said, the revision number translates to the level of believability. So the higher the number, the more believable. So when we go in and we look at this, a transparent switch has a revision number of 0, like I mentioned previously, which means it's not going to be believed. Revision numbers are going to increase by 1 for every change. So if I come in and I say VLAN 10, hit enter and type exit, that's going to increment my revision number by 1. If I also go in and say create VLAN 11 to 400 and then I exit out, that's still going to increase my revision number by 1. So it's not per VLAN, it's per change. Therefore, it's going to be each time the database gets altered. So it's not based on the number of VLANs, but the number of times the VLAN gets changed. Now, the idea here is remember I mentioned the fact that clients can't create databases. Now, a client can't create a database. That poses a question. And what I'm going to do is let's go to the main whiteboard here, since it'll probably be more fluid with regard to writing. Let me change that out. So, what am I talking about? Well, I'm talking about the fact that if I have a series of devices that are interconnected, so let's say I have SW1 connected to SW2, connected to SW4, connected to SW3. And again, we're interconnected this way. I'm not going to close this loop. And what I'm going to do is I'm going to say this device is going to be my server. Now, what I'll do is let's pretend that I'm going to populate changes, and those changes are going to be sent to each of these devices. Let's say these devices are all clients. This one's a server. But SW1, SW2, and SW4 are all clients. Now we know that clients cannot change the database. Bear with me just one second here, guys. I'm sorry. They can't change the database. i.e., I can't come onto these devices and say create a VLAN. However, if I receive an update that says create VLAN 100, what will happen is I will create VLAN 100 here, and then I will also forward that message to all of my neighbors. Now the idea here is that in this entire unified domain, now we should have VLAN 100. Now what we have to recognize here is we have two behavioral situations. We have first the idea of a transparent switch, and then we have the idea of this client and this VTP bomb. So let's go through and look at this. Now we said that I could create a series of VLANs. So let's say I created 10 VLANs. So we'll create 101, 102, 103, 104, 105, 106, 107, 108, 109, and 110. Now, by virtue of that fact, let's say we created each of these individually. So that's going to give me a revision number of 10. Let's say this device already had a revision number of 2. So what's going to happen is this is going to be a revision of 12. And each device, if my VTP domain is fully operational, each device would synchronize on a version or a revision number of 12. Now, in this situation, that's great and wonderful. But let's look at this. Let's modify this scenario. Because remember, 4, 2, and 1 are all clients. So what we're going to do is we're going to pretend that we take 4 out of service. Now remember, the moment we take 4 out of service, we've just killed its link. We have not disabled VTP. VTP is still running. But the problem is with this link down, we're not going to receive any updates. So we'll have no updates. Now, in this process, what ends up happening here is that let's say we go in and we make a change to the servers, and what we'll do is we'll make each of these guys transparent. So SW1, SW2, and SW3 are now transparent switches. Now that means that the VLAN database is going to be okay, but notice our revision number, like I said, is going to go to 0. Now what ends up happening now is that these databases, or this revision number, is not going to be propagated because remember, they're all transparent. Well, we realize, or we make a call and we say, well, that's a bad idea. So what we're going to do is we're going to take these switches out of transparent mode. Now, let's pretend that the moment that we bring them out of transparent mode, we put them back into client. Now, the problem is that we have all of our VLAN information, and we have this revision number now that is going to probably be, well, we take them out, it'll be 1. And then we bring this link back up. Now, the moment we bring this link back up, this device says, hey, I have a revision number of 12. These devices, let's say, just for argument's sake, let's say their revision number is now 5. Well, what's going to happen is that an update is going to go out, and the system is going to look at it and say, oh, it's 12, I have a 5, therefore my database on this device must be out of date. So what I'm going to do is I'm going to dump all of my information, and then I'm going to apply everything I learn via this update 12. And then what's going to happen is this update is going to get propagated all the way through our infrastructure, which means everything is going to resynchronize on this idea of the revision number 12. And this is what's referred to, I call it jokingly, bear with me one moment, I call it jokingly referred to as the VTP bomb. I mean, it makes it sound so ominous. VTP bomb. Now, I used to really talk this down a lot. And then I was in the middle of a demonstration in class, and I decided to go from a 4 topology device to a 3 topology device, very similar to what I just described here. And I just left the 1 unit set over. And in the interim, I'd made all these changes. And what I ended up doing is when I was going to do my layer 4, I'm sorry, my layer 3, my IPv4 routing protocols, I decided I needed to bring all 4 of my switches back in, and I wanted to leave everything in and operational. But what happened was by virtue of the fact that I had killed the link on SW4, it actually blew my entire VLAN tables out. So for the purposes of my demonstrations in a live boot camp, I had to recreate all of my VLANs, which was kind of a bit of a consternation. But it definitely made me aware of the fact that this is something that we want to avoid when and where possible when it comes to working with this notion of VTP, VLAN Trunking Protocol. So keep in mind the idea of this VTP bomb. All it really implies is based on a higher revision number. We have the capability of overriding the database. And the thing that is the single point of confusion for most students is the fact that we have the capacity to overwrite the database even if we're a client. Because remember, we're still going to be sending information out. And what we're going to do is we're going to look at some debugs that's going to walk us through these scenarios. And I'm going to show you the fact that this idea of the VTP bomb, it's really not, I mean, again, like I said, it makes it sound like it's some kind of thermonuclear device that's running in your network the moment you turn VTP on. Well, that's not the way it works. And what we see here is going to be one of the best ways to protect ourselves from having this happen. And why would I say having it happen? Well, VTP uses authentication. Again, remember, the ability to be identified, that a neighbor is who he says he is, and before or up until they validate this authentication, I'm not going to believe anything that I hear from that neighbor. Now, the main thing here is, and this is where I really see issues with VTP in the past, and that was, again, a number of years ago, where an organization gets a switch. They order a new switch, they take the old switch out, and what they do is they take the old switch and they put it in the back, and they allow some guy like us that's going to be studying for their CCIE to bang on it. Well, the thing is that what they end up doing is later on, so let's say we lose a switch and somebody says, oh, well, we've got a switch in the back, go grab that switch. And they bring it and they plug it into the environment, and what ends up happening is if they do not remember to remove the VLAN.dat file and to make the configuration changes, like what I recommend a lot of people do is you just take your switches to transparent and then bring them back up into server. It's going to clear the entire configuration with regard to the revision number, and before you introduce them into your infrastructure, or just zeroize them. Take them back to factory default. That's the best solution. But do not forget to remove that VLAN.dat file. Now, what will happen here is authentication doesn't really help us that much, because if this switch would still have the password that it had when we took it out, it could still have this process or enable this process of being able to blow out our entire infrastructure. Now, recognizing the fact that with regard to VTP, we do not send clear text passwords. We use MD5 hashes. These MD5 hashes are going to be exchanged, thereby we keep the password secret. But the problem is in version 1 and version 2, the password is going to be visible. All I got to do is type show VTP password, and it's going to give me the password. Again, an optimization that they decided they were going to modify or change in the context of version 3's VTP deployment configuration. So keep in mind, there's no clear text passwords, and the fact that we're going to be sending these MD5 hashes. But the other thing is keep in mind our our message digest, our domain names must match. So again, we're not going to form a relationship with another device unless they do. And remember, I talked about the fact that VTP has direct entanglement with our DTP, our dynamic trunking protocol, that we're going to be running on our dynamically formed links. That's also something that I want to make certain that we take the opportunity to take a look at. Excuse me one moment here. Now, in spanning tree, when we create these trunks, I talked about the fact that we can control what VLANs are going to be able to traverse what links. Well, VTP has a very interesting utility referred to as VTP pruning. VTP pruning allows me to say, well, if I'm going to be running this information, I do not necessarily want to flood information for VLANs that I don't need to know about or my neighbors don't need to know about across a link. And it's basically just an optimization. Again, a way of ensuring that we make certain that we bound information on links with regard to what data we're going to be sending, what frames we're going to be relaying through our infrastructure at layer 2, forwarding through our infrastructure. So the idea here is VTP pruning is again a tool. It's a tool that's going to allow me to reduce the number of broadcast, multicast, and unicast, unknown unicast messages I'm going to forward. So the idea here is if I have SW1 connected to SW2, connected to SW3, and I have VLAN 10 here, VLAN 10 here, but I do not have VLAN 10 configured on this switch. Why would I want to burden this link with sending broadcast messages, multicast messages, or unicast, unknown unicast messages for VLAN 10? So what's going to happen here is what we can do is on a server, we can enable VTP pruning. Now what will happen here is that we're going to now have that information propagated as part of our updates. Until ultimately what's going to happen is every device in the structure is going to inherit the VTP pruning configuration. Now, once it's inherited, what's going to happen now is we're going to say, I'm going to send messages to my neighbor for the VLANs that I need. So let's say I needed 20 to 30, but I do not need 10. Well, what's going to happen is by virtue of the fact that my neighbor, SW3, on SW2 is not sending me requests for VLAN 10, I'm now going to prune VLAN 10 from this link. 20 and 30, or 20 through 30, are going to work perfectly fine, but by virtue of the fact that my device is telling me that he does not need VLAN 10, then I'm going to stop sending the information. But let's expand this argument. Let's say now what I do is I have SW4 in the mix. And SW4 does have 10, has VLAN 10 that it needs, which means it's going to send that request to SW3. SW3 now knows that its neighbor, SW4, needs VLAN 10, so what's going to happen is it's going to start sending the requests for it so that SW2 knows to send it across that link. So that's all there is to VTP pruning. Now what we have to recognize is that we have a list. It's called the prune eligible list. Now the prune eligible list is going to be a list of all VLANs that can be dynamically pruned from a link via our VTP pruning mechanism. Now if we take a VLAN off of that list, that means now it cannot be pruned. So what we may have to do is in situations where we have VTP pruning enabled and we have a transparent switch in our infrastructure, remember that transparent switch is not going to request VLANs. It's not going to send information out. It's not participating in VTP. So we may have a scenario whereby if SW2 was a transparent switch and it had 100 on it and I needed 100 for transit all the way through my infrastructure, I may need to go to each of the devices that are connected to SW2 and say remove 100 from the prune eligible list. So the logic is the same with regard to our VLAN allowed list, but the VLAN allowed list says, okay, if you take it off this list, it's not allowed on the trunk. In VTP pruning, if I take it from the eligible list, it means VTP can't prune it. So it's got to be allowed. So the logic is slightly reversed, but the main idea here is VTP pruning is a useful tool. Now again, like I said, the majority of offices that I see do not run VTP. Some are entertaining VTP in the context of the version 5 exam because of the V3 component and some of the capabilities, the security enhancements, and the optimizations that were integrated to it. And like I said, we'll talk about that in its own section. So when we go through and we look at VTP enabled switches, all right, it is going to exchange VLAN information that is locally assigned. So that means if I create a VLAN on a switch, the switch is now going to say, oh, I need to communicate the fact that that VLAN exists on my or in my database locally to my neighbors. The other thing here is it's also going to have to notify its neighbors about the VLANs that it's transit for. Remember that scenario where SW4 said I want VLAN 100, but VLAN 100 has not locally been configured on SW3. SW3 is going to receive that request and realize that, oh, I need to transport this VLAN, so it's going to actually send it out. So that will also be communicated. So it's going to be VLANs that are locally configured on an individual device and VLANs that are being communicated by neighbors that are directly attached to our switch. Those are going to be the VLANs that are going to be requested with regard to being sent, therefore not pruned. Now what will happen here is any other VLANs that are not needed will not be allowed on the trunk between the devices unless I override that behavior with my prune eligible list. Now the idea here is really just boils down to the simple fact that there is the hazard where if I have a transparent VTP device in my infrastructure, remember it's not going to send messages out. Therefore we have the capability of having our traffic being black holed, especially if we're running VTP pruning. So guys, this wraps up our conversation. Let's go into the demonstration for VTP. We'll look at it. We're going to play around with VTP in the context of being able to communicate information with version 1 and version 2. Once that's over, we're going to return and have a theoretical conversation about the enhancements for version 5, and then we'll hit it on the console. So I'll see you guys there. Bye-bye.